Hello to everyone. In the last video for today I decided to solve one more competitional question. Let's read the problem. If x on 13 is equal to a given number, which is a large one, find x. This is an interesting question, but quite hard. It looks too simple, but it is not, believe me. Let's start. Let's denote the given number with, for example, a. First natural approach is to try to bound this number, actually to see in which range this number is. To do that, firstly let's see how many digits a has. If we count the digits, we can conclude that a has 26 digits. This means a is between 10 on 25 and between 10 on 26. So, x on 13 is greater than 10 on 25 and less than 10 on 26 power. The right hand side of these inequalities is very appropriate because 13 is divisor of 26. And let's work with that. Since x on 13 is less than 10 on 26, we can take root 13 here and we will get x is less than 10 on 26 over 13, which is 10 on square. So this implies x is less than 100. This is a nice bound. So we already found the upper bound. Let's try to find the lower bound. So we need to work with the fact that a is greater than 10 on 25th power, or x on 13 is greater than 25th power. Because of that, let's try to figure out what to do. We have 10 on 25th power. That is not appropriate because 25 is not divisible by 13. Let's review that term. We have 10 on 25 or 25th power, same, is actually 2 times 5 on 25, which is 2 on 25th power times 5 on 25th powers. So we need to work with 2's and 5's. Realize that 5 on 4th power is equal to 625, which is greater than, I'm looking for a power of 2, greater than 512, which is 2 on power 9. We get 10 on 25 power, 2 on 25 times 5 on 25, which is greater, or firstly let's go equal, 2 on 25 times, I will write this 5 on 12th power, 5 on 13th power. Or let's go in reverse, 13, 12. And this is 2 on 25 times 5 on 13 times 5 on 4, then on power 3. And now, because of this, 5 on 4 is greater than 2 on 9, this will be greater. 2 on 25 times 5 on 13 times what? 2 on 9, then on power 3. And this is exactly 2 on 25 times 5 on 13 times 2 on 27, sorry. And this is equal 2 on what? 52 times 5 on 13. And this is exactly what? 2 on 4, then not on 13, times 5 on 13. and this is 2 on 4 times 5, everything on power 13. 16 times 5, which is 80. 80 on 13. So we have x on 13 is greater than 80 on 13, which implies immediately x greater than 80. I will circle this and denote with 2. Look at 1. X was less than 100 and greater than 18. So by 1 and 2, we get x is between 80 and 100. This is a nice fact, actually. If we want to check, we will check a small amount of values, but the point is that the number is too big and we cannot check in any way. Also, let's try to figure out what to do next. Let's look at the number. The number ends in 9, which is very interesting. The only powers of digits which could end on 9 are which? Let's write that. The only powers of digits which could end on 9 are 3 could end on 9, 3 on second power, for example. 5 cannot, 7 and 9. But between 3 on 13, 7 on 13 and 9 on 13, only 9 on 13 ends on 9. So I will not write since, so x ends on 9. But it is between 80 and 100, and this implies that x is 89 or 99. And now, what to do? We have two very nice facts between 80 and 100, and now I actually have just two choices because of the last digit. Let's see, is this number is divisible by 9? If it is, then x must be divisible actually by 3. If we count the sum of the digits, that is the criteria for divisibility with 9, we can see that the sum is, I think it is, just to check, 107 if I'm not wrong. And then the number will not be divisible by 9. So we have one more another conclusion. If we check the sum of the digits of A, we get that S of A, the sum of the digits, is equal to 107, and it is not. So this means that the number A is not divisible by 9, and so A is not divisible by 9, and this means so 3 doesn't divide x. And the only possibility between 89 and 99 is actually 89, and the conclusion follows. Hence, x must be 89, and we are done. Thank you for watching. Please subscribe if you like the video. See you next time. Bye bye.